Good evening, students. In this class, I explain the term equilibrium constant Kc and Kp, and also derive the relationship between Kp and Kc. Let us consider a reversible reaction. X moles of A reacts with Y moles of B gives L moles of C and M moles of D. Here A and B are the reactants, C and D are the products. X, Y, L, M are the stoichiometric coefficients of A, B, C and D respectively. X, Y, L, M is stoichiometric coefficient of A, B and C and D respectively. Apply law of mass action to the forward reaction. Law of mass action states that the rate of the reaction is directly proportional to the product of the active masses of the reactants. Law of mass action is the reaction rate is directly proportional to the product of the active masses or molar concentration of the reactant. Okay. So, if you apply law of mass action to the forward reaction, so forward reaction apply panina, rate of the forward reaction is directly proportional to the active masses of the A to the power of X, B to the power of Y. Okay. So, rate of the forward reaction equal to Kf. This is the rate constant for the forward reaction. A to the power of X, B to the power of Y. Okay. Similarly, if you apply law of mass action to the reverse reaction, reverse reaction apply rate of the backward reaction is directly proportional to the concentration of C to the power of L and D to the power of M. Or rate of the backward reaction is equal to rate constant for the backward reaction into C to the power of L, D to the power of M. Okay, is it clear? At equilibrium, the rate of the forward reaction is equal to rate of the reverse reaction. At equilibrium, rate of the forward reaction is equal to rate of the reverse or rate of the backward reaction. So, Kf A to the power of X, B to the power of Y is equal to Kb C power of L, D to the power of M. Okay. Kf by Kb is equal to concentration of C to the power of L, D power of M by A power of X, B to the power of Y. This is nothing but Kc. You have the equilibrium constant. Okay. So, equilibrium constant is at a constant temperature, the ratio between the product of the active masses of the products rise to respective stoichiometric coefficient in the balanced equation to that of the reactant is a constant. அதாவது கான்ஸ்டன்ட் டெம்பரேச்சரில் ப்ராடக்டினுடைய ஆக்டிவ் மாஸுடைய பெருக்கல் பலனுக்கும் அதனுடைய பவர் பார்த்தீங்கன்னா ஸ்டாஷியோமெட்ரிக் கோஎஃபிஷியன்ட் இருக்கிற பவர்ஸை இருக்கணும். டு தட் ஆஃப் த ரியாக்டன்ட் இஸ் எ கான்ஸ்டன்ட். இதுக்கு பேர் தான் ஈக்குலிபிரியம் கான்ஸ்டன்ட். ஈக்குலிபிரியம் கான்ஸ்டன்ட். ஒன்ஸ் அகைன் ஐ ரிப்பீட், ஈக்குலிபிரியம் கான்ஸ்டன்ட்னா at a constant temperature the ratio between the product of the molar concentration or active masses of the products உடைய active masses உடைய பெருக்கல் பலன் rise to respective stoichiometric coefficient stoichiometric coefficient in the balanced equation to that of a reactant is a constant. It is known as a equilibrium constant. இங்க சிம்பிளா சொல்லலாம். equilibrium constant ratio between the product of the active masses of the products to the product of the active masses of the reactant. அதாவது ப்ராடக்ட் உடைய ஆக்டிவ் மாசஸ் உடைய பெருக்கல் பலனுக்கும் ரியாக்டன்ஸ் உடைய ஆக்டிவ் மாசஸ் உடைய பெருக்கல் பலனுக்கும் உள்ள ரேஷியோ சிம்பிளா இப்படி சொல்லிட்டாலும் போதும். ஓகே, இஃப் A and B and C D are gases, இப்போ gases இருந்தா ஓகே, அதாவது if reactant and products are gases இருந்தா the equilibrium constant can be expressed in terms of partial pressure. Equilibrium constant can be expressed in terms of the partial pressure. So Kp சொல்லணும். Okay, if A, B, C, D are gases, அப்போ equilibrium constant expressed in terms of the partial pressure. So Kp equal to partial pressure of C to the power of L, partial pressure of D to the power of M divided by partial pressure of A to the power of X, partial pressure of B to the power of Y. Is it clear? Next, very important 5 mark question. Relationship between Kc and Kp. What are 5 marks? Relationship between Kp and Kc. Okay. Consider a reversible reaction. Okay. Consider a reversible reaction. X mole of A plus Y mole of B gives L mole of C, M moles of D. Okay. Applying law of mass action, we get Kc equilibrium constant in terms of the concentration. Kc equal to C to the power of L, D to the power of M by A to the power of X, B to the power of Y. Okay. Kp equilibrium constant in terms of the partial pressure. Kp Pc to the power of L, Pd to the power of M, Pa to the power of X, Pb to the power of Y. Okay, we know gas equation. Pv equal to nRT. So pressure equal to N by V RT. Pressure equal to N by V RT. Active mass, that is nothing but molar concentration. Active mass is molar concentration, that is equal to N by V. So pressure equal to N by V is active mass. So pressure equal to active mass into RT. Okay, pressure equal to active mass into RT. Using this equation, either use பண்ணி we can write the partial pressure of A and B and C and D. Okay, by using this expression, we write the partial pressure of A, and we will repeat Pa to the power of X is equal to pressure equal to active mass into RT. So partial pressure of A to the power of X means active mass of A to the power of X, RT to the power of X. Similarly, Pb power of Y equal to active mass of B to the power of Y, RT to the power of Y. Using this expression, we can write the partial pressure of A, B, C, D. So partial pressure of C equal to active mass of C raised to power L and RT to the power of L. Pd equal to active mass of D to the power of L, RT to the power of L. Okay. So substitute the partial pressure value in this equation. Equation number 2. For 2 lo padum. So Kp equal to Pc power of L என்னது இது பண்ணும். Okay, this is all. This is L. Okay, clear. So Kp equal to Pc to power of L means C power of L RT to the power of L, Pd to the power of M, D to the power of M, RT to the power of M divided by A to the power of X, RT to the power of X, B to the power of Y, RT to the power of Y. Next step. Kp equal to, we collect concentration term first. For C to the power of M, D to the power of M by A to the power of X, B to the power of Y, RT to the power of X plus Y. Okay. X plus or X plus M divided by this is RT to the power of X plus Y. Okay. So Kp equal to C to the power of L, D to the power of M by A to the power of X, B to the power of Y into RT to the power of L plus M minus X plus 1. Exponent வந்து work போது separate பண்ணலாம். So Kp equal to, this is nothing but Kc. Okay. So Kc into RT to the power of, we can write this as delta Mg. Where delta Mg means difference between the number of the moles of the gas, total number of the moles of the gaseous products and the gaseous reactants. Once again repeat. Let us consider reversible reaction. Xa plus Yb gives Lc plus Md. Equilibrium constant Kc expression is one. Kp equilibrium constant in terms of the positive pressure. We know Pv equal to nRT, P equal to NBV/RT, active mass equal to molar concentration, that is N by V. So pressure equal to active mass into RT. Okay. Using this expression, we can write the partial pressure of PA, PB, partial pressure of ABCD respectively. You know, PA to the power of X na A power of X, RT to the power of X. PB power of Y na B power of Y, RT to the power of Y. PC power of L, C power of L, D to the RT to the power of L. PD to the power of M na D power M, RT power M. Next, substitute the partial pressure value in the Kp expression. Okay. Next, correct concentration term. Okay. Next, this is nothing but Kc. So Kp equal to Kc RT delta H. Delta H means L plus M minus X plus Y. Okay. Next. So Kp relation is Kp equal to Kc into RT to the power of delta M. First case, when delta Mg is equal to 0. Example, H2 gas plus I2 gas gives 2HN. For this reversible reaction, delta Mg is 0. Delta Mg is 2 minus 1 plus 1, 2. Total number of moles of the gaseous product to reactant 2. Okay. Similarly, N2 gas plus O2 gas gives 2NO. In this reaction also, delta Mg is 2 minus 2, 0. When delta Mg is 0, Kp equal to Kc into RT to the power of 0 or Kp equal to Kc. Okay. When delta Mg is positive, so positive are. For example, decomposition of PCl5 gives PCl3, okay, plus chlorine. For this reaction, delta Mg is 2 minus 1 plus 1, 2 now, total number of moles of product is 1. So positive. Another one example, decomposition of ammonia. Ammonia decomposed into N2 plus 3H2. For this reaction, delta Ng is positive. இப்போ பாசிட்டிவா இருந்தா Kp equal to Kc into Rt to the power of positive. So Kp is greater than Kc. Kp அதிகமாக இருக்கும். Okay. When delta N is negative, third case, delta N is negative. For example, next example na H2. H2 plus O2 gives 2H2O. For this reaction, delta N is 2 minus, okay, 3 minus 1, negative. Okay. Similarly, ammonia formation of ammonia. N any example, N2 plus 3H2 gives 2 ammonia. For this reaction, delta N is negative, minus 2. If delta N is negative, Kp equal to Kc into Rp to the power of negative. So Kp equal to Kc by Rt to the power of positive. Rt. So Kc equal to Kp into Rt to the power of positive. So Kc is greater than Kp. Kc is greater than Kp. Okay. Next stage. இது ஒரு பாயிண்ட் நீங்கள் தெரிஞ்சுக்கணும் ஃபார் யூஸ்ஃபுல் ஃபார் நீட் ஆல்சோ. ஃபார் எக்ஸாம்பிள் XA YB gives LCMD. For this reaction, suppose if the equilibrium constant is Kc are equilibrium constant for the forward reaction. So forward reaction equilibrium constant Kc are. If the reaction is reverse panina, Lc plus Md gives Xa plus Yd. For this equilibrium reaction, Kc dash equilibrium constant is equal to 1 by Kc. So இது எப்படி இருக்கும்னா 1 by Kc. Second, suppose A converted to B. For this equilibrium constant K1, B to C equilibrium constant K2, C to D K3, then A to D K4. இப்படி இருந்ததுன்னா K4 equilibrium constant is equal to K1 into K2 into K3. Okay, that's all. This is very important. Relation between the Kp and the Kc. Thank you.